let's talk about something huge that's happening right now in the world of software. A massive shift, all powered by AI. And while everyone's buzzing about this idea of coding by vibe, we might be missing a really critical danger. So in this explainer, we're going to dig into how to navigate this brand new landscape. Indri Karpathy really hit the nail on the head when he called it vibe coding. It's this perfect name for what's happening. You have an idea, you tell the AI what you want, you get some code back, and you just kind of steer it by feel. It's incredibly fast, super intuitive, and yeah, the whole industry is hooked. But in all this excitement, we've started to blur a really important line. And that's where the trouble starts.
See, the thing is, vibe coding isn't really just one thing. It's actually split into two very different paths. One path is what you'd call responsible, AI-assisted engineering. But the other? Well, it's something a lot riskier, something we're going to call trust coding. We absolutely have to understand the difference.
And this right here, this is the core difference. With professional AI-assisted engineering, the human is still the expert in the loop. The AI is a powerful tool, sure, but you verify its output. Your trust is calibrated. With trust coding, that whole relationship gets flipped on its head. Suddenly, the AI is the authority, and the operator, who might not even have the expertise to double-check the work, just deploys the output based on, well, blind trust. So let's just nail down this definition. Trust coding is what happens when you take AI-generated code and ship it without having the skills or the process in place to actually verify it. You see, the problem isn't the AI itself. It's the absence of those checks and balances. And that absence, it's injecting a brand new kind of risk into the software we all use. To really get a handle on that risk, we need to talk about a core concept, non-determinism. You know, for decades, the tools we use to build software have been built on a rock-solid foundation of predictability. And AI? Well, it just dropped a big, powerful, unpredictable element right into the middle of everything. Think about the traditional way of doing things. It's super clear, right? A human brings the creativity, the messy, unpredictable part, and turns it into source code. But from that point on, the whole process becomes completely mechanical. A compiler is deterministic. It follows the exact same rules every single time. It's a reliable machine. Now, take a look at the new toolchain. We've jammed a large language model, an LLM, right in there, between the human's idea and the actual source code. And here's the twist. The LLM is also creative and non-deterministic. It makes guesses, it improvises. We've basically put a second, unpredictable, almost human-like step right into the heart of our very mechanical process. And the scale of this change is just staggering. I mean, look at this. The odds of a compiler making a mistake because of some random hardware fault, it's practically zero. But the chance that an LLM makes a subtle little logic error, it could be as high as 1 in 10. We are talking about orders and orders of magnitude more uncertainty here. Now, that's not a reason to panic, but it is a totally new reality we have to build for. Okay, so this kind of shift, it's not entirely new. History actually gives us a fantastic model for understanding exactly what's going on. Every time a new, higher-level tool has shown up, we've seen a very similar pattern play out. Just think about it for a second. In the 70s, C didn't get rid of assembly. It built right on top of it, and that's what made portable operating systems possible. Then, in the 90s, Python didn't replace C. It built on top of that, which led to the explosion of the web. Each new layer of abstraction doesn't kill the old one. It just massively expands what we can build. And AI? Well, it's just the newest, highest layer yet. So this creates what you could call the expanding software pyramid. This new AI layer at the top makes building software accessible to millions more people. But, and this is so important, the foundational layers, the stuff built with languages like C and Rust for performance and control, they don't go away. In fact, the more stuff you build on top, the stronger that foundation has to be. So the demand for real, deep expertise down there can actually grow. So what's the direct result of all this? Well, when you make development accessible to millions of new people, a lot of whom are not experts, the whole spectrum of quality just gets wider. More software gets built, which is great, but the average quality level, kind of the floor, is at serious risk of dropping unless we build new guardrails to support this huge new wave of creation. And that leads us straight into the central challenge of this new era, quality assurance. When a machine is writing the code, how on earth do we make sure that code is correct, that it's safe, that it's reliable? Who is checking the checker? And
The most obvious, most tempting question is right here. You've got to be thinking, hey, if an AI is smart enough to write code, then surely it's smart enough to find its own mistakes, right? Just have the AI do the quality control. It sounds so efficient, but it's fundamentally, deeply flawed.
The reason this whole idea failed is because of something called the tautology problem. And to put it simply, a system cannot be a reliable checker for its own systematic blind spots. The best analogy is trying to proofread your own writing. You know what I mean? You miss your own typos all the time because your brain already knows what you meant to say. The very same blind spot that caused you to make the error in the first place prevents you from seeing it. An LLM is exactly the same. Its statistical patterns will cause it to just glide right over the very bugs it created. Real true verification has to come from an independent perspective. Okay, so if the AI can't check its own homework, what do we do? Well, we have to build new guardrails. This isn't about throwing out the tools. It's about developing a professional playbook for using them safely and really, really effectively. And here it is. This is that playbook. And you'll notice that every single one of these strategies is designed around one critical idea: independence. First, you write a clear spec before you generate any code, so you have an objective ruler to measure against. Second, you use behavioral tests that check what the code actually does from an outsider's perspective. Who cares what it looks like inside? Third, you can even use a different AI model to try and break your code, to find weaknesses. And finally, you focus your precious human expert time where it matters most, on the highest risk parts of your system. When you boil it all down, it really comes to this. The most important skill in this new age of AI-assisted development, it's not prompt engineering, it's calibrated trust. It's knowing when the tool is likely to be right and when it's likely to be wrong. It's knowing which outputs you can accept, which ones you need to review carefully, and which ones you just throw away. So that leaves us with one last thought. The tools are always going to be new. The languages, the frameworks, now even the very act of writing the code itself, that all changes. But our fundamental responsibility as people who build things, that never changes. Our job is to create things that work and to understand exactly how and why they do. That is the one constant.